Hello, my name is Jared Skeens and welcome to the Zoom room. Today we'd like to cover Statistics 1, Data Representation, Location, and Spread, Part 4, Cumulative Frequency Graph. So again, with the cumulative frequency, just like we saw in Part 3 with the histogram, you have to pay attention to the difference between discrete and continuous. So if you haven't looked at that yet, you might want to go back to Part 3 with the histogram, and I cover the discrete versus continuous. Remember, discrete is individual, or can only take specific values, where continuous can take any value over a particular range. And you need to have continuous data, again, with the cumulative frequency. So let's get to an example. This one we'll get to later. I want to get to one that is actually on a test paper here. So I'm going to share the screen. And here we see an example question here from a Cambridge past paper. And in this particular example, they provide the cumulative frequency graph for you. So let's make a few observations here. Says Ransha measured the lengths in centimeters of 160 palm leaves. His results are illustrated in the cumulative frequency graph below. So here's a couple of things that you need to pay attention to on a cumulative frequency graph, whether, especially if they provide it for you, but even if you have to make it yourself. First off, the labels, don't forget the labels. Your y-axis will be the CF, or the cumulative frequency. Just like in histogram, the y-axis was the frequency density. In cumulative frequency, the y-axis is the cumulative frequency. So make sure you label that. And then on the bottom here, the x-axis is whatever your units happen to be, whatever your topic happens to be. So make sure you read the question carefully. So it's talking about lengths in centimeters. So down here at the bottom, you see the label lengths in centimeters. So your x-axis, again, is going to come from the class boundaries provided from the data set. Now, because they graphed it for you, they don't show you the data set. They just show you the result in the graph. But this down here would be your class boundaries. And then this along here is cumulative frequency. Now make sure you pay attention to the difference between frequency and cumulative frequency. Cumulative frequency adds up the frequencies as you go. Frequency is just the number of data points in each particular grouping or class boundaries. So frequencies is individual groups. Cumulative frequency adds up as you go. And make sure if you're looking at a table, you pay attention to whether they give you frequency or cumulative frequency, because they are different values, and you need to know which one you're working with. For this graph, you need the cumulative frequency, so make sure you're working with that. Also, notice the bottom of the graph does not have to start at the origin. It might start at the origin. It does not have to start at the origin. So this lowest value here at the x-axis will be the leftmost, the lowest boundary of your lowest class boundary group. So notice up here is the 25. That would be your highest value of the upper class boundary. And then the 5 here is the lowest value of the lower class boundary group. So this one, say, may have went from 5 to 10 and 10 to 15, something like that. We don't know because they don't provide it. But this 5 would be the least value in the data set. Okay, so that's where it starts at the x-axis, is that least most boundary in your data set. Also notice that as the curve, a normal cumulative frequency curve has kind of this stretched out S shape. You can see a little bit of an S shape there, but it's kind of stretched out. So that's going to be what your graph kind of sort of should look like, preferably a curve, although sometimes you might end up with line segments depending on how the data falls on the chart. And when you graph it, we'll get to this again later, but you're going to graph your data points with the uppermost boundary of each class boundary group. So in other words, if your class boundary was from 5 to 10, then you take the cumulative frequency and you graph it on the 10. If your next one was from 10 to 15, you take the cumulative frequency and graph it on the 15, and so on. So you graph the cumulative frequency with the uppermost boundary of your class boundaries. I'll point that out again later. So this here is the result. Now, either way, whether you produce the graph or they provide it for you, you're going to have to answer some questions, and the questions will generally involve mean or median or quartiles or percentiles, can even be percentiles, and it can even be, you know, interquartile range, those kind of questions. So let's see what kind of questions they put with this. And you need to be fairly accurate. Now, here it says, estimate how many leaves have a length between 14 and 24, okay? How many leaves have a length between 14 and 24 centimeters? Notice this units is in length. So we need to come back here, and I'm going to expand this. Can I expand this a little bit? I don't know if I'm, oh, whoops, there we go. Try to expand it a little bit. So we want 14 to 24 of length. Now, pay attention to your scale. So for 5 units, there's 10 little boxes. That means you have to go 2 boxes for one number. So here's 10, so 2 boxes over would be 11, 2 more boxes, 12, 2 more boxes, 13, 2 more boxes, 14. So this is 14 right here. And what I would suggest is you use a straight edge and your pencil, because you have to be very accurate. Don't just look with your eye. Don't just follow your pencil up. Draw a straight line with a straight edge exactly where it's supposed to be. Draw it up from 14. This is where 14 is at. Follow the cursor there on the screen. Follow it up until you hit the graph. And notice you hit the graph right here. And then go over to find out how many. So this is over here. Now look on the side here. You have 40 to 60. That's 20. And there's 1, 2, 3, 4, 5 boxes. So 20 divided by 5 means each box represents 4. Down here, 2 boxes represent 1. Over here, 1 box represents 4. So again, you follow this line from 14 up till it hits the line, then you follow it over. Now, my estimate on this would have been 56, 1 box. Let's expand it up here again. So this one here is 15. 14 is this line right here, 2 boxes over. This is 14. Do you see my cursor right there going up and down? And so this goes up and it hits right there. Notice if I put the cursor right on the lines, right on the grid lines, the dark line of the graph goes just slightly below it. You might not even notice it. So I would have estimated 56 because 1 box represents 4. So we're one box down from 60, means this is 56, but the line is actually slightly less, so it might be like 55. Okay, you need to be very, very accurate. Now let's go over here to 24. Here's 20. So 24 would be this line right here, 14 to 24. We follow it up here, going up, slide down, and we get to this point right here, and we follow it over. I don't know, hopefully you can follow it over there, and we're at what I would have called 156, okay? So I would have come out right here, which again, one box is 4 below 160, so that's 156. Let's go back and blow this up again, and notice again that if I put that right on the grid mark, the line is just slightly below the grid crossing, where the grids cross at, just slightly below. So if I were to just have briefly looked at it, I would have said 156 and 56. And it says how many are between them. So 156 minus 56 is 100. That's would have been my estimate. Well, if you look really, really closely, you can see that the line goes just below it. So maybe I would have put, if I had blown it up so I can see better, maybe I would have put 155 minus 55, and I still would have gotten 100. Well, the thing is with this, that when you look at the mark scheme, let me just show the mark scheme here really quick for you. Notice it says this. It does say 156 for the top end, and it says 55 for the bottom end. It gives its answer as 99. Remember, my answer was 100. Here it says it should be 99. Now over here on the right, it gives you a window of acceptable values. Now generally, if you're careful, Cambridge generally gives you a fair window of possible answers according to the accuracy of the graph. In this particular example, I think that they should have included the 100. Notice it says the answer has to be between 98 and 100, including the 98, because you can see the or equal to, but it doesn't have the or equal to on the 100. So technically my answer of 100 would not have been accepted. I would have lost this point. So personally, I think that their window is a little unrealistic, since a person with a test paper cannot blow it up like I could on the computer and get that better view, and it depends on how good your eyes are. I think the 100 should have been included, but you can see you could have 98 or 99 and it's acceptable. So the point isn't for me to complain about the mark scheme. The point is to show you that you need to be quite accurate on these questions. Don't just casually glance at it. Use your straight edge, draw the lines very carefully, pay attention to the scales, and make your best judgment. So like I said, usually their windows are fair, and you should be able to fall within the window that they provide using the accurate graph paper. So I just wanted to point that out. Now let's go to their first question here, or second question. We already answered this, between 14 and 24 centimeters. Now it says 10% of the leaves have a length of L centimeters or more. Estimate the value of L. Now this one is called a percentile. They didn't use the word percentile, but it gave it to you as a percent. We've already talked about quartiles. Quartiles are every 25%. A percentile is just any particular percentage that they choose to give to you. In this case, 10%. So the 10 percentile, actually in this case, it says that these leaves, 10% of the leaves, have L centimeters or more. Now this is an important detail, so please take notes on this point. Cumulative frequency graphs give you the less than value. What do I mean by that? Let's go back up to the graph. Let's say we take 100 here. 100 would be right here, and you come down, means that 100 of these total 160 leaves have a length of, and I'm just going to roughly call it 16 here just for sake of discussion, okay? So these 100 leaves have 16 or less. Notice you read the cumulative frequency from your origin. That means from the 0. So anytime you are using a cumulative frequency graph, you're reading it from the origin, from the less than. Now this particular question says or more, meaning you're going to the greater than side, right? So if you're talking about 10%, if you can follow 10% of 160 is 16. But you don't go 16 from the bottom. 16 from the bottom is the less than group. This one said or more. So if it's or more, meaning we have to take 10% from the top. So anytime you're doing or more, and if you're with the y-axis, you're dealing with the top. If you're on the x-axis, you're dealing with the right-hand side. Okay, so if you're or less, then you're dealing with the left-hand side of your x-axis, or you're dealing with the bottom part of your y-axis. Okay, so I hope you're able to follow that. But pay attention to less than, more than. Your graph is automatically calibrated to less than. So this said 10% has a certain length or more, so that or more tells us we want to take it from the top. So 10% of 160 is 16. And here's another thing to pay close attention to. Notice the number on your y-axis goes all the way up to 180. But 180 is not the high value on your graph. The high value on your graph is 160. Be careful of that. Don't take 10% of 180. Either look up into the question and you see 160, or look at the top of your graph and follow it across to its value. 160 is the number you're working with, not the 180, so please be careful of that. Some students take 10% of 180 and they end up with the wrong answer. So 10% of 160 is 16. 16 from the 160 then is 144. So here's, let me blow it up here a little bit. Remember, every one box represents 4. So 40, there's 144 right here. That would leave 1, 2, 3, 4 boxes left. 4 times 4 is 16. Okay, so we're at 144. Follow it across. Use your straight edge and your pencil to follow this across. And you reach this spot right here and follow it down. Let's see if I can keep on that line pretty good there. And we follow it down to right here. So notice 20, here's 2 and 2. So that's 20, 21, 22. Okay, now let's look at this, and 22 is what they got. Now you should show on your paper that either you took 10% of 160 and then subtracted it from 160, or since you're taking it from the top, you can call it 90%. If you subtract 10% from 100% and you take 90% of 160, you get 144. So either way, you should show that you ended up with the number 144. So either 10% of 160 subtracted from the top, so subtracted from 160 to get 144, or you take 10% from 100% and get 90% of 160 is 144. And when you follow that through, notice you get 22. So we're in agreement there on that one. And it was pretty exact, so they don't give you a window of possible answers there. You have to hit 22. Then they asked, let's go back to the next question, shrink this back down. So we did that one, we've done this one, and now we need to estimate the median and the interquartile range. So the median is the 50% mark, and the interquartile range is Q3 minus Q1, or the 75% mark minus the 25% mark. So let's go back here, span this up a little bit so we can see what we're doing. So again, remember 160 is your top value. So 50% of that, or the median, will be at 80. So if you follow 80 across, you get here. Now notice that is in between this mark and these two lines, just past this one here. So if we follow that down, this one is 15 and this one is 16. Two boxes is one. So this is 16 over here, and this is just past the first line. So this would be 15.5. So your answer should be above 15.5, but it's closer to the 15.5 than it is to the 16. So let's say 15.6 for the median. Let's check that out. And for the median, yes, they get 15.6. Notice they say that it has to be between 15.5 and 15.8, not including the 15.5 or the 15.8, meaning the only two values you're allowed, 15.6 or 15.7. Again, it's a very tight window. Use your straight edge and, pay attention to that scale and try to be as accurate as you possibly can, because it is a tight window. So now let's go back to this one and work on our quartiles. So if 80 is the middle, that means 40 is quartile 1. 40 would be quartile 1. Again, if you take 1/4 of 160, you get 40, or 25% of 160, you get 40. You follow this across and you get here. Let's blow that up a little bit. And notice we are between these two lines. Well, here's 10, here's 11, here's 12, here's 13. And we're between, this one was 11, 12, 12 and a half. Here's 12 and a half, and here's 13. So we're at maybe 12.7. So let's say 12.7. Now let's go up here to halfway between 80 and 160 is the 120 mark. That's 3/4 of 160, or 75% of 160 is 120. So this is the third quartile. Follow it over and we get to right here. And notice it's really close, but just before this line here, which is 2 units away from this dark line. So come down here, this was 20, this is 19. It looks like it's just in front of the 19. So we call that maybe 18.8. what, 18.8. So what did we have? About 12.7 and 18.8. That gives about a 6.1. If you take the 18.8 minus the 12.7, you get 6.1 as your interquartile range. So let's look at this. And they get 6.1. They did get 18.8 and 12.7, and they allow you an interquartile range of 6 to 6.2, including both of those. So you can have 6.0, 6.1, or 6.2. We got 6.1, which was really good. Again, your upper quartile, by the way, upper quartile, the UQ means your upper quartile. That's the same thing as Q3, the third quartile. And LQ is the lower quartile, which is the same thing as your Q1, the first quartile. So it says your upper quartile should be between 18.5 and 19, not including the ends. And your lower quartile or first quartile should be between 12.5 and 13, again, not including the ends. And you subtract the two to get your interquartile range. So again, quite specific, but you can get it. Then so we did that one, we did that one, we have now done that one, and the next one is box and whisker, which we already did a box and whisker plot before, so I'm not going to do that one right now. You can look back at video part 2 where I cover the box and whisker plot. So let's get rid of this one now, and let's see an example where you have to do the cumulative frequency graph yourself. So let me just show you the problem here through screen share so that you can see. So this is what we're going to work on. I already have it on the board, but I want you to at least see the problem. It says last Saturday, 200 drivers entering a car park were asked the time in minutes that it had taken them to travel from home to the park. The results are summarized in the following cumulative frequency table. So here you have minutes of driving time from home to the park. Notice the second row is cumulative frequency, which is what you want for a cumulative frequency graph. Sometimes they give you frequency, meaning you have to calculate the cumulative frequency yourself. So pay attention to which one they give to you, frequency or cumulative frequency. And they want us to do several things. So I'm just going to go through the questions first because I already have most of it on the board prepared for us to save a little time. So they want a cumulative frequency graph. We'll do that. They want to estimate the median, the middle, from our graph that we make. And they want to find the time taken of 80 drivers that was at least t minutes and find the value of t. And also they want us to calculate an estimate of the mean. So they want us to predict the mean time. And we'll talk about that one as well for the 200 drivers. Okay, so like I said, I have this on the board. So let me stop sharing right now and let's go to the board and see what we have. First thing that we're going to look at is when you look at these cumulative frequency questions, you want to look at the graph that they give to you or the chart that they give to you and look at discrete versus continuous. That's the first thing you should check. Both histograms and cumulative frequency have to have continuous data. So that's the first thing we're going to look at. And we see this says t less than or equal to 10. Notice they don't give you a left-hand side. Also notice I've left some space here. In their chart, they don't leave you any space. But when you see groupings that just have the right-hand boundary, it means the left hand is assumed or understood. So if your time is less than or equal to 10, obviously you can't have negative time. So this is going to be an understood 0 with just a less than. In other words, you can't instantaneously show up at the park. It takes time to drive there. So you're most likely not going to have a 0 time, although it is in minutes, I guess, if you had less than a minute. But if you want to put the equal to, it doesn't really matter. We can include the 0 if you want. So this includes the 10. So this one is going to go from 10 to 20, but we can't include the 10 because it's already included in this one. This one has the equal to for the 10, so we can't include the 10, but this will be from 10 to 20. This one then is from 20 to 30. This one then is from 30 to 50, and this one then is from 50 to 70, and this one is from 70 to 90. So if I'm working with it, one of the first things I'm looking for is this idea of continuous data. The numbers do repeat if you compare it with the understood value that's supposed to be there, or that you can supply. So we have 10, 10, 20, 20. There's no gaps. So this is already continuous data. Okay, so that's the first thing that we're looking for. The second thing that we're looking for is whether they give us frequency or cumulative frequency, okay? Because your graph is a cumulative frequency graph. So if they give you frequency, then you need to add them up as you go. So 16 for this group, 34 for this group, gives you a total of 16. Remember, it's starting from the origin, so from 0. By the time we get to 10, we have 16 data points. From 0, by the time we get to 20, we now have 16 plus 34 is a total of 50 data points. So you need to add up the individual frequencies as you go. So then 16 plus 34 is 50, plus 56 is 106. So you need to make sure you have cumulative frequency, not just individual frequencies. So that's the second thing we look for. Now, our part I was to draw the graph. So again, remember to put your labels. So the y-axis is our cumulative frequency. The x-axis is dealing with time in minutes. So make sure you put your labels. You'll lose a point if you don't have your labels. You also need to choose a scale. Even if they provide you nice graph paper, you still need to choose your scale. I don't have the graph paper up here, so I kind of have to freehand it a little bit. But having graph paper makes it nice, but you still need to choose your scale. So for the y-axis, you have 200. So what I did is I just put a 200 up here at the top of my line, and then I took half of that is 100. Half of that is 50. Halfway between 100 and 200 is 150. And then I did half of each of those. So half of 50 is 25. Halfway between 50 and 100 is 75. Halfway between 100 and 150 is 125. And halfway between 150 and 200 is 175. So since I was doing it freehand, I broke it down by halves, and it makes it a little bit more consistent. You're going to have lines to work with. You still need to choose your scale. Then for the x-axis, the highest value is 90. So again, I just went by tens. So 10, 20, 30, 40, 50, 60, 70, 80, 90. And I tried to make my increments the same distance apart. Again, if you're working with graph paper, that will be easy for you. So you still need to make it out to 90. Then you need to figure out where your starting point is. Remember when we looked at the previous example, your graph does not have to start at the origin, what you look for is your furthest most left or your least class boundary. So on the previous example, it had started at 5, meaning this number right here in that first class boundary would have been a 5 on that previous example. In this case, it is 0, so our graph is starting at the origin. But just remember, it does not have to start at the origin. I see some people making graphs, they graph the points, and then when they get to the last line, they just automatically connect it to the origin. Don't do that. Don't automatically connect your last point to the origin. Make sure you're looking at your smallest value here. That's where you want it to connect to the x-axis. So this one does happen to be at 0. Then when you graph a cumulative frequency graph, so pay close attention again, when you graph a cumulative frequency graph, you graph the cumulative frequency with the upper end of your class boundary, the upper end of your class boundary. So at 10 on the x-axis is where I go to 16 on the y-axis. Then at 50 goes to 20. So 20 on the x-axis, 50 on the y-axis. Remember, this is the x-axis, cumulative frequency is the y-axis. So you're graphing each cumulative frequency with the upper end of your class boundary. So at 10 or 10, 20, 30 is 106. Then at 50, we graph it to 146. So here's 146 at 50. It jumped. It didn't do every 10. It went from 10, 20, 30, and then it jumped up to 50. So careful to follow those upper boundaries. Then 176 with 70. And then at the end, your last dot should be at your highest point or the total. So 200 with the 90. Okay, so it doesn't matter if your y-axis goes up higher, you graph the 200 with the 90. So here's the 90, here's the 200, that's the upper end there. So when you graph it, again, hopefully you end up with this kind of stretched out S shape. It should be somewhat curving up at least to the halfway point, and then it should be kind of curving out to the right for the second half. Generally, that's how it works, because as your cumulative frequency gets over that halfway point, you know, it goes up kind of quickly, and then it you know, spreads out towards the end. So this S-shaped curve can be shifted a little bit left or right, but generally it's going to have that S shape to it. Try to make it a curve, but if you have to do line segments, you can, they'll accept it. But hopefully it has a little bit of a curve shape to it. So that's how you want to graph it. And so you get points again for your scale, you get points for your label, and you get points for every value that you put on your graph accurately. That is cumulative frequency with the upper boundary. And then make sure you start at the correct place on your x-axis. So this is the graph. Not too difficult, especially if you have graph paper. It's a little bit more challenging to do it freehand, but if you're careful, you can do it. Now, if you look over here on the left, we have our questions. The second question was to find the median. Well, the median is the middle, so halfway of 200 is 100. Notice I used dotted line. Use your straight edge. Get a straight edge up there, run it across until it touches your graph, and then go the other way vertically and do a straight edge down until it hits your x-axis. So median is the 50% of 200 is 100. Follow it across till it hits your graph, then follow it down. Notice I'm between 20 and 30, so I guessed 28 was my guess, but this is freehand. I don't have any grid lines to follow. So notice I got 28. They said it should be between 28 and 30. So actually I didn't do too bad for freehanding it. 28 to 30, including the 28 and the 30. So we're good on that one. Now, part III said that 80 of these cars had at least T minutes. At least means that's going to be your smallest number. So it actually means 80 of these cars were more than or greater than or equal to the T minutes. So again, we have a more than. Remember your graph does less than. So if this 80 is more than, we need to start from the top, not from the bottom. So if it said 80 is less than T, we would go to 80 and find out the time that was less than a particular value. But since this is at least, meaning more than T, then that means we need to start from the top. So I show my work, 200 minus 80 recognizes that I see the more than, or the upper part. So this is more than, this towards the origin is less than, and towards the outside is more than. Okay, so from the outside we go down 80, which takes us to 120. So this dotted line is at 120, which is just below the 125 there. I follow it across and I follow it down, and I come up with a value of 34. Again, I freehanded it. I get 34. Actually, they want an answer between 36 and 39. So I missed it by a little bit, but I don't have grid lines to follow. So 36 to 39, including the 36 or 39, or, and if you look at the mark scheme, it says or FT. FT stands for follow through, meaning you followed through on your own graph. Now, if you have graph paper that you're using from the Cambridge exam, then you should have gotten 36 to 39 because you already have the lines there to help you. I don't have the lines, so if we're using my graph and you can see that I got the right value of 120 and I follow through with that and end up with 34, as a follow through, my 34 is okay for this graph, but it should have been between 36 and 39 if you have good graph paper, okay? So I want you to understand how the mark scheme works as well. Then they ask for the mean. Remember, the mean is the sum of the frequency times the mid-class value divided by the sum of the frequency. They didn't give us frequency, they gave us cumulative frequency. So we need to go back and calculate our frequency. That's why I put a frequency row here, because we're going to need that to do the mean. If actually in their question, they didn't give a row for frequency, they just give time and cumulative frequency. So you might need to make your row below the cumulative frequency. So just remember, cumulative frequency, this one is 16, therefore your frequency is 16. Your cumulative frequency is 50, so 50 minus 16 is 34. If you're going from frequency to cumulative frequency, you add. If you're going from cumulative frequency to frequency, you subtract. So 16 plus 34 is 50, that's the cumulative, or 50 minus 16 is 34. 106 minus 50 is 56. 146 minus 106 is 40. 176 minus 146 is 30. 200 minus 76 is 24. So those are our frequencies for each grouping, each class boundary, individual frequencies. Then we also need the mid-class value because we're dealing with average. Average is more towards the middle. It's not the extremes. So between 0 and 10 is 5. Between 10 and 20 is 15. Between 20 and 30 is 25. Between 30 and 50 is 40. Between 50 and 70 is 60. And between 70 and 90 is 80. So these up here are my mid-class values. So to find the mean, we need to take the sum, or adding up, frequency times mid-class value. So notice we get 16 times 5 plus 34 times 15 plus 56 times 25 plus 40 times 40 plus 30 times 60 plus 24 times 80. Add all that up and divide it by the sum of your frequency, which is your 200. All these frequencies should add up to 200. And you divide by 200 and you get 36.55. Now, notice I put 36.55 and not 36.6 to three significant figures. Why? Well, because when you divide it on your calculator, you get exactly 36.55. So if your answer is an exact value, meaning your decimals don't run off the screen, it stops. 36.55 stop. That's exact. So if your answer is exact, you should leave it exact, 36.55. What three significant figures is for is when your decimals run off the screen, and obviously you're not going to write all those decimals down, so you round it to a certain level of accuracy. And your level of accuracy, according to Cambridge, should be three significant figures unless they say otherwise. So don't change this to 36.6, although if you look at the mark scheme, they do accept it just in case someone did do three significant figures. But because it's exact, you don't have to change it, okay? Because the decimals stopped. So only if the decimals keep going, that's when you do three significant figures. And so you can have 36.55. They would accept the 36.6 if you had put that, okay? So here we've been through cumulative frequency. We've looked at percentiles, quartiles, interquartile range. We've looked at frequency and cumulative frequency. We've looked at mid-class values. You graph to the upper class of the upper boundary of the class. A lot of different terminology, a lot of different details. But again, it's a way of representing data representation. So hope you can keep track of all these details. I hope you took good notes. We've now went through 4 different graph types. And again, thank you for joining me, and look forward to seeing you again next time.